Flipped classroom video for Maths AS Unit 1, Basic Trigonometrical Equations. First of all, trigonometry doesn't just come up in triangles. When we've solved trigonometrical equations previously, there have been one or sometimes two solutions, and this is because we've been dealing with triangles which have a total of 180 degrees. So with triangles we're only concerned with angles in the range 0 to 180. And there we can see sine, cos and tan shown just up to an angle of 180. So for cos and tan we can see that in that range they have unique values. So if we came across an equation like tan theta is 1.2, we could draw across from 1.2, drop down, and that would be the same as solving this equation, so saying theta is tan to the minus 1 of 1.2, and from the graph we could see that theta is about 50, and if we need it to be more accurate we could use a calculator. For sine theta sometimes we get two values, and we saw that in the solving triangles video. We had to solve sine of this angle xyz is 0.694, and first of all we found sine to the minus 1 of 0.694, which gave us 44 degrees, but then we looked at the fact that the sine curve goes up and then down again down to 180, which means that this value of 0.694 hits the graph in two places. The first place was at 44 degrees, but then it hits again, and because of the symmetry of the curve, the second place it hits is 180 minus 44, so that gives us our second solution. And that means we have 44 and 136. And you can see that on the picture now, so there's the dotted line going across at 0.694, and then it hits at 44, and then at 136. Now, you might do a different method for finding the other values. There's one called cast or ASTC, which uses the unit circle. There are also formulae that we've come across already in these videos, and you'll have come across at school. But this graphing method is a good and versatile method. So let's have a look at full circle trigonometric equations. A basic example, we're now looking for all values of x in the range 0 to 360, and they need to satisfy cos x is equal to 0.891. So step 1 is we find the basic value of x, so that means we have to use x equals cos to the minus 1 or arc cos of 0.891, and the calculator would give us 27 for that, with decimals, but roughly 27. Step 2, we would sketch the curve of y equals cos x from 0 to 360, and it looks like that. Step 3, we'd mark our existing solution onto the graph, so we go across from 0.891, hit the curve and go down to 27, or vice versa. The next thing we do is the line going from 0.891 across, we carry on until we hit the curve again, and then we drop down. So where the green line hits the x-axis is going to be our value. And then step 5, we use the symmetry of the graph to determine this value, and we can see that that value is 27 degrees from the full circle of 360, because the graph is symmetric about 180 degrees, and therefore we can deduce that that value is going to be 360 minus 27, or 333. And as I mentioned before, as well as cast, there are these formulae that hold for angles and for the trig functions. So you might already know that cos of 360 minus x is the same as cos x. But there are risks involved with that. It's easy enough to get those equations mixed up if you're under pressure. So sometimes it's easier to use a graph, but you'll find your own way as you do lots of practice. And finally we can put that answer there and add the degree signs because we've finished. Oh, as it says, we only use the degree symbol when we give our final answers, otherwise it's a faff. Okay, trigonometric translations, and this is where we start looking at changing the range that we're dealing with. So we need to find all the values of x in the range 0 to 360 degrees, which satisfy sine of x minus 50 degrees is equal to minus 0.682. So in this case, the first step is to find the basic value of x minus 50 degrees. And we do that in the usual way, so x minus 50 is equal to sine to the minus 1 of this minus 0.682, and that gives us minus 43. The next step, which is really important, is to establish the range of values of x minus 50. We're given the range of values for x, but because we're dealing with x minus 50, we might need to go outside that range for x minus 50 in order to come back into it, which will become clear as we carry on. So we start off by saying that x lies between 0 and 360, and then in this inequality, if we subtract 50 from each term, the inequality still holds. So we then have minus 50 is less than or equal to x minus 50 is less than or equal to 310. And that means we're only interested in that range in this question. So, step 3, we would draw the sine curve with the new range in mind. And there it is. Step 4, we'd mark our existing solution as we did before. So that's at minus 43, and we're going across from minus 0.682. Then we would extend that line and draw vertically up from where it hits the curve. So we first hit the curve there, and we use the symmetry of the graph to determine this value of x. And again, this time, because sine is symmetrical about 90 degrees, we know that the distance across from 0 to minus 43 must be the same as the distance from 180 to this new value. So that means we have 180 plus 43 equals 223. Now at this point, you may be wondering why we haven't carried on the green line to hit the curve again. If we did, that would then be 360 on from our original value, because that would be a full circuit of the sine curve, and that would give us minus 43 plus 360, which would then take us outside our range for x minus 50, because 360 plus minus 43 is 317, and that is greater than 310. Okay, so we now know that our other value for x minus 50 is 223, so I've put that back into the working on the left hand side, and we get to the final step, step 7, which is to calculate the values of x. And a nice way to do this is to say that x will be the minus 43 plus 50 and the 223 plus 50, and then we can work them out and we get our final answers of 7 degrees and 273 degrees. Now, it's a good idea to check your answers back into the original equation for trig questions. So you could do that if you like. Pop these values into your calculator and see if they're correct. But it's a good practice. It's something you could do, say in an exam, you could do at the time of answering the question, or you could make a little note in the margin for yourself, and when you're checking back through, just check your final answers, and if they're correct, you've probably got the working right, and if they're not, you know you've got to go back and find out where the problem is. Moving on, spotting the tangent. So this time we're going to have to rearrange an equation and use a previous bit of information. So let's see what we've got. We're looking to find all the values of theta in the range 0 to 360 that satisfy cos theta minus 5 sine theta equals 0. Now, we don't want sine and cos in the same equation. So essentially what that means is we need another equation which involves sine and cos so that we can eliminate one of them. And we have two choices. We know that sine squared theta plus cos squared theta is equal to 1, and we also know that tan theta is equal to sine theta over cos theta. So, step 1, since we don't have any squares, we'll use the second of these. And first we rearrange the equation. So we have 5 sine theta equals cos theta, and that means sine theta is 1/5 of cos theta, which means sine theta over cos theta is 1/5. And you can see where we're going with this. So in step 2 we replace sine theta over cos theta by tan theta, and that means we can find our basic value of theta. So we have that tan theta is 1/5. We can then use arctan or tan to the minus 1 to determine that theta is equal to tan to the minus 1 of 1/5, which is 11.31. Step 3, now we can use a graph or cast or one of the trig equivalences to find any other values of theta. So we're going to use a graph, and there is tan between 0 and 360, and we mark our original solution. So I've put 1/5 as 0.2 because it is equal to 0.2. We then go across and down, and that is 180 along from the original, or we can think of it as the original little distance of 11.31, which you can see there from 180. Either way, that gives us 180 plus 11.31, which is 191.31. And again, just to reiterate these equivalences, since tan of x plus 180 is the same as tan x, we could use this here safely, since it has become a relatively straightforward tan question. Anyway, finally I've put the answer back up into where we were writing for step 2, so we've got our 2 answers there with their little degree symbols. Another thing that we need to be able to do with trigonometry is that there are a lot of equivalences, and these can be very useful in some situations, but of course all of them have to be derived or proven. So you might be asked to do this, and the absolute golden rule with this is you start with one side and you do work, algebra and various things to find the other side. So in this question we've been asked to prove that tan of phi times sine of phi plus cos of phi is the same as 1 over cos of phi. And remember, the triple equals symbol means is the same for all values. So it means it is literally the same thing. Okay, so for this question, as stated and reiterated, we're going to start with one side, and in this case we're going to start with the left hand side and work towards the right hand side. So we have tan phi sine phi plus cos phi. Now the first thing we do is we replace tan phi by sine phi over cos phi, so that gives us sine phi over cos phi times sine phi plus cos phi. The next thing we're going to do is combine the sine phi's in the first term, so that's going to give us sine squared phi over cos phi, and also because we've now got cos phi on the bottom of that fraction, we're going to multiply the second term by cos phi over cos phi, which will also give us a cos phi on the bottom. So that gives us plus cos squared phi over cos phi. Now you can probably see what's happening. We're going to combine those fractions, so we're going to add them up, and because we have a common denominator we can simply add the numerators, so we get sine squared phi plus cos squared phi over cos phi. And now what will become an old favourite, it is an old favourite for me, maybe already an old favourite for you, but it certainly will become one, and that is that sine squared plus cos squared is 1. Whatever we have there, I've put theta there even though it's phi in the question, doesn't really matter. And that allows us to say that we now have 1 over cos phi. So we started with the left hand side, we did some maths, and we found that that was and is equivalent to the right hand side.